room as well. So the slides in this room, do I have to start them?
Yeah, can you?
Yeah.
Okay, perfect.
There.
Okay. All right.
Did you share your screen on Zoom?
He already has a micro.
Oh, sharing the wrong screen.
There's a screen.
Oh, okay.
Wait.
I think it's a bit difficult setup.
Okay.
Komm mal raus.
Go ahead. I thought it's already sharing. Ah, okay.
Yeah.
And then this one, yeah. Okay. Perfect. You guys see my screen in Bonn?
We got it, thank you.
Okay, perfect. So yeah, thanks everybody for coming. I want to talk about fundamentals of trustworthy AI. It's one of the research areas at Lamar. And before I go into the details, I want to start with a quote that you all can or cannot read. Actually, now you can read it. Ernest Hemingway once said, "The best way to find out if you can trust somebody is to trust them." I think this is a really nice intro to the topic because it sort of questions what we actually think of trust, what the word actually means, and that's what I want to talk about today. So we all know trust is a critical concept of our modern world. We all trust each other, or do we? Big questions. We all use technology. Do we trust it? So when we talk about humans, we have to think about, do we trust each other? That's the fundamental thing. Two people trusting each other. What is the prerequisite for trust? Then maybe we have a society, a group of people that has trust or not trust, that maybe trusts in society, maybe not everyone in the society actually trusts the society, so it's actually a very complex thing. Then we have science, and we are now in a time where there's a lot of distrust actually in science. A lot of people do not trust the scientific system that we have, which for us as researchers is a big problem. How can we make sure that this becomes trustworthy? We have technology that we use every now and then, and we trust them. We trust technology. We go on planes, we take the car, whatever. Is this technology that is actually trustworthy? And this, of course, also leads into AI and robotics. Is AI trustworthy? Big question. So we want to find that out today. First, a bit about myself. So I'm Raphael. I'm a computer scientist and AI researcher at TU Dortmund and, of course, at Lamar Institute. I finished my PhD on sustainability and trustworthiness of machine learning and AI. But as I said, I'm coming from a computer science background, which might not be true for everyone. Is everybody from computer science here, or are there people outside of computer science? No one outside of computer science? Maybe this makes the whole thing even more interesting for you, because I feel that we as computer scientists, we are always a bit like locked in our views on technology and AI. So I'm always interested in interdisciplinary projects and transfer. So that's going to be one thing that I also cover in this talk. And also as a side information, I'm also heading the Young AI Leaders here in Dortmund. I'm going to come back to that a little bit later. Might be interesting for you guys if you want to do some collaboration on using AI for good. Right. So the agenda of the talk, it's sort of straightforward. We first talk about what is trust. Then we talk about, is AI trustworthy? Then we question how we can actually make AI more trustworthy. And then we discuss a bit about regulation, and this also leads into the second talk of today. So, starting with the first question, what is trust? Very fundamentally, the important thing is that the matter of trust has a lot of different dimensions coming from different disciplines. So, for example, we could ask people from psychology, what is trust? And they will answer, well, there's definitely a cognitive dimension to it. So it's entailing an expectation, and we receive something as input, and we see whether that matches with our expectation. And then, of course, there's an emotional dimension as well. So when we trust someone, we become vulnerable to them or to it. And one thing that is really important is calibrating these things. So trust calibration is research. Oh, the pointer doesn't work. Oh, it works at the screen. No. Oh, what? Oh, it does work. It's just a bit... Oh, it doesn't matter, I'm just going to show it here. So calibrating trust means that we sort of balance over trust and under trust, which can lead to misuse and disuse. And then the two specific things that we do to calibrate trust is we dampen trust or we repair trust. So that's sort of the psychological perspective on trustworthiness. Then we also have a sociological perspective on the whole thing. So individuals in our society might actually rely on very impersonal systems. So not about trusting humans, but actually trusting systems, trusting governments, trusting technology. And this trust is actually culturally embedded. So when asking people all around the world, do you trust something? Do you have trust in something? It's actually quite diverse. So there's countries that sort of have a rather high amount of trust in itself and in the system and everything that is making up their daily work and daily world. And there's other countries that are actually very much in the negative direction, that actually don't trust things around them. So that's really interesting, keeping in mind that AI comes from only a very few of these countries. Thinking about trust in AI is also a question of trusting culture in a way, or like trusting being from different cultures. Another aspect that we have to take into this is the ethical dimension. So in the ethical perspective, trust is linked to normative expectations and to a moral demand. And this means that in addition to reliance, there might be some extra factor concerning trustworthiness. And this would be something that just sort of can be framed as a goodwill or responsibility to do something useful, something responsible in our world. There's a certain commitment for doing things right. And this basically is the ethical perspective, saying like, we have a reliance, and for example, we have computational reliabilism, we have transparency, but there's an extra factor that is really hard to assess for AI. So how does this relate to sustainability? Because I did my PhD on sustainability, so everybody would now be would be reasonable to ask why I'm now talking about trustworthiness when I'm actually researching on sustainability of AI. So sustainability, for those of you who don't know it, and sustainable development aims to balance the demands of the society, economy, and environment. That's sort of the fundamental idea of sustainable development. And to me, this is very much trustworthy. So it definitely falls together. In sustainability, we, for example, have the Sustainable Development Goals, which were sort of motivated and manifested in the Agenda 2030 by the United Nations. And when you look at them, this actually pays into this goodwill and this extra factor from an ethical perspective. So when we look at different research fields about AI and machine learning, it actually all comes together. In Lamar Institute, we have trustworthy AI and resource-aware machine learning. You heard about resource-aware machine learning last week. And there's a lot of other fields like responsibility, safety, fairness, efficiency, explainability, accountability. And to me, this all can be nicely summarized under the framework of sustainability and these three dimensions of sustainability. And there's actually even a duality of sustainability and trust. So there was a work from 2021 by one of our PIs actually saying AI has a twofold role for sustainability. On the one hand side, we can use AI for sustainability. And to me, this would be a trustworthy use of AI. This means that we use AI to drive positive change in our world. And there's a lot of different things we can do. There's projects that use AI for good, that use it to sort of mitigate climate change and reduce the problems of climate change and all the problems connected to it. There's initiatives like the Young AI Leaders, and there's so much literature on where we can use AI for sustainable development. On the other hand, we also have to look at the sustainability of AI. And to me, this relates to the untrustworthy use of AI. AI actually can be seen as a threat to our world. There was a big international AI safety report coming out earlier this year from interdisciplinary and international experts, like the biggest names you can imagine in AI, writing about the problems of generative AI, agentic AI, and potential general artificial intelligence, AGI. There's a lot of research talking about the power consumption of AI. This, of course, relates to SDG 13, to climate action. So there's a lot of resource consumption in the whole field. You heard about this last week. Then there's claims that we actually already live in an age of surveillance capitalism, just because we have so much concentration of power in AI relating to very few actors, very few companies, very few countries, and they basically make all their money by surveillance capitalism. And of course, this whole thing of like growing models and growing compute expenses can also be visualized. And this all is sort of untrustworthy, right? Right. So having that out of the way, let's come to the second question. Is AI actually trustworthy? Who here thinks that AI is trustworthy? Okay, I'm not surprised with the introduction I gave. Any of you who actually thinks AI is trustworthy? Not in Dortmund, at least. I can't see Bonn right now. Hard to see. That's actually the thing that is actually manifested. It really depends on how you frame this question. So a big global study that came out this year was saying that over 60% of people on a global scale use AI regularly. This would mean that they sort of trust the system, right? Because they use it all the time. So there's a certain amount of trust definitely in this technology, otherwise they wouldn't use it. But when you ask people, less than half of the people are actually willing to trust AI systems. And this is a big gap, right? So there's a lot of people that think that the use of AI will result in a wide range of benefits. There's also a lot of people that believe that regulation is necessary. There's a lot of people that use AI and don't really check on the accuracy. So they just use it and don't really check if it's accurate or not. Actually about the same amount as people that use AI. But still people don't trust it. So it's really a paradox thing that we currently have. And I think this is something that we need to discuss and talk about. Why is that coming from? Why people do not trust AI but still use it all the time? So key characteristics and extra factors of human trust are really hard to apply to AI. AI does not have integrity, doesn't really have emotions, doesn't really have empathy, goodwill, morality, culture. It's basically just a stochastic parrot repeating all the things that we as people put into the internet and just repeating that all over again. But what I post on the web, or any of you posts on the web, has some sort of integrity. You have a moral character behind that. You have a certain belief in something. And if you're not trolling the internet, then you also put this into your posts. But collecting all these different things, all these different emotions, integrities, and different moralities, and building a model from that, you lose this individualism in a way. And this means that models might cause harm. And there's 3 dimensions, as this IBM Think article talks, there's 3 dimensions of harm. So it can harm people, it can harm personal rights, it has impacts, potential negative impacts on physical and psychological safety, discrimination, and also democratic participation. In organizations, we have maybe harms for the business operations and the reputation of a business, monetary loss, of course, also coming into that. And we have ecosystems, resource consumption, the financial system, supply chains, the environment, the planet. This actually very much sounds like the 3 pillars of sustainability, right? So this is another evidence of why I think these 2 topics are super connected. Let's go into another aspect of trustworthiness. I already talked about this bigger is better paradigm. So when we look over time, we see models just exploding up in terms of training compute and also inference compute, especially since the start of deep learning in 2010. I asked myself when I started my PhD, why is this actually happening? Where does this bigger is better paradigm come from? Why is it happening in the field? Even though people know it's bad, but it's still happening. I think it's untrustworthy ML values. And this actually goes back to a paper from the FACT conference, which is also interdisciplinary, where people from other disciplines investigated what are the values that people sell in machine learning. When you write a paper, you put like some sort of motivation into it and say like why your work is relevant for publication. This is the value of your paper, right? The value for the scientific community and also the value for the world in a way. And when you look at these values encoded in machine learning research, you hardly have any form of justification and connection to societal needs. You don't really have discussions of negative potential. And you don't really have a justification why predictive performance is the thing that you optimize. Everybody is optimizing the error and the accuracy, but nobody really like reasons why this happens. Of course, we want to have models that are very predictive, but it's still very much an over-focus of our community. And of course, behind that, we have a high centralization of power. So a lot of these like top conference papers are actually coming from corporate power. They come from Google Research, Google DeepMind, Microsoft Research, all that. And they definitely have their place in this world. But I think that the centralization of power is pushing this sort of bigger is better paradigm. And it's really hard to compete with that. So how can we make AI trustworthy? Of course, this is also the questions that we ask ourselves at Lamar Institute. Well, we have to map technical AI properties to human requirements. Sounds a bit weird at first, but when you look back to the think back to the first slide, we have these different characteristics which we as humans have to sort of make something trustworthy, on the reasons why we basically trust things. And we have to find a way to map this to technical properties of AI. And this, of course, also requires to integrate all different areas of ML and AI research. So for example, we have to look and care and discuss and research on accountability. So there's different reasons and different motivations here, but the main thing is whatever AI does needs to be somehow aligned with human strategies and human plans, and we have to think about who's accountable if anything happens that should not happen. Another aspect that we have to focus on is robustness. So we have to prevent damage, we have to increase security, we have to build error resistance, we have to minimize errors, we have to build a sort of defense against outlying behavior, and there's a lot of studies on AI systems, especially deep learning systems, behaving very unpredictably and very unrobust in a way. When you take this image, clearly shows a school bus, you just apply some noise to it, it gives you a result that we as humans don't see any difference in. Suddenly it's an ostrich. Super weird. Definitely not true, right? Like the image still shows a school bus. It looks exactly like not exactly, but very much like the original picture, but the AI is fooled because of that. You can also do this in real life. You can just put small stickers on a traffic sign, and suddenly the AI doesn't detect the stop sign anymore, which is big things, and this is basically research on robustness. Privacy is a big issue, of course. We have in the European Union, we have the GDPR, but in other countries they have not. What still is the case is that ML and AI, of course, needs data. That's the whole origin of the whole thing. And we have to look at quality of data, but we don't really have a way to do this in a privacy preserving way. So we're losing our individual rights because we give away our data, and AI models are trained on that. When people now build LLMs, they usually use parts of the data in the internet, and there's things like Creative Commons, which you can use, I guess, but the people that put content into the Creative Commons 20 years ago, they probably didn't agree that AI models in 20 years will be trained on this data. Otherwise, they might have changed their vote on that. Another aspect that we have to talk about is explainability, of course. This is sort of the biggest research field in trustworthiness, I would say. So the big models that we have, like image classifiers, vision models, language models, all the big deep learning models, they are super intransparent. They are super obscure. We don't really know what's happening inside. We just know it's billions of parameters interacting with each other. That's about everything we get. So we don't really have an idea of why a specific input maps to a specific output. And this, of course, does not really sound very trustworthy. There is interpretable models. Wherever possible, we should use them. But a lot of the state-of-the-art results in AI are just not achievable with interpretable models. So explainability research tries to bridge that gap. And also, just as a short teaser here, I did a lot of research on these labels, basically as a way to give a global explanation of model properties, not for a specific decision, but for general properties of an AI model. That also allows that to comprehend the properties of AI without expertise in the field, right? Because AI today is not only used by AI experts, it's also used by everyone on the internet, basically. Another thing we have to talk about is fairness. So we have big problems with diversity and bias in AI, and especially in image and language models, deep learning models, where it's just taking all the data that is out there and learning something from it. Well, the data out there comes from society, and society has biases. It's not so long ago that people weren't allowed to, like women weren't allowed to vote. So if you look at statistical data, you could say, well, women shouldn't be allowed to vote because they weren't allowed so for the last 1,000 years. Like, why should we allow them to vote? Historically, it doesn't make sense, right? We know this is not true. We know this is super problematic in the context of discrimination and bias. But when you ask AI models, generate me images of architects, janitors, doctors, or teachers, you see a strong bias in that, right? And this affects everyone. And maybe you're cis-white without any problems with that, but as an AI field, this makes us very untrustworthy, and you have to deal with this, definitely. And for example, there was also this whole thing that Amazon, for example, did like pre-selecting of people that apply for their jobs based on their CV and all that. And we don't really have good ways. I mean, all these are research fields, right? So there's definitely work happening in that end, but this is all like important research that needs to happen in the context of trustworthiness. Responsibility is another thing that I just want to mention. This goes back to this ethical aspect. So we have to think about how we can advance social and ecological well-being and social impact. Maybe there's just applications that we shouldn't do, like using chatbots based on Twitter threads, right? Now X threads. But I'm sure most of you have seen online discussions that you would not want to train a model on, because you know online discussions might not be the most responsible and most ethical way to talk about things. Reliability, of course, very much connected to robustness. And there's also some other factors that I just want to mention here. So it's usually called epistemic trust, meaning if you actually trust the information that is coming to you. So you're communicating some sort of information. Question is the information itself trustworthy? And does the information make the whole thing that it's describing more trustworthy? So you have to question, do we actually trust science? Do we trust institutions? AI is currently used all over the world to steer elections and to change democratic systems, maybe destabilize democratic systems. We have this aspect of surveillance capitalism. So how do we deal with this, and how can we basically deal with epistemic trust issues? Right. So breaking this down, coming to a conclusion to this question, I think all of these research topics are super complex in itself. And of course, there might be other research fields that I haven't mentioned here. And I think trust calibration would necessitate to really advance them in interdisciplinary ways and improve this mapping from human requirements to technical AI properties. Okay, I want to take a little bit of time going into my specific research, just because I'm giving this talk, so I might as well dump my own research contributions into this. So one thing I asked myself, how can we better report on model performance and especially acknowledge the trade-offs and the user priorities? So I mentioned before, the whole field is overly focused on advancing predictive quality, which is a problem. And I think there's always trade-offs. If you get more quality, you usually also spend more resources. So you have a trade-off to that end, sort of a Pareto trade-off. And in order to basically be better than that, we have to first start with a really solid characterization. So we have to characterize the model that we use, the execution environment, so the hardware that we use, and the data set we use. From that, we can build a database of machine learning evaluations with properties of different models. This could also relate to like human factors, of course. And then we can use a software framework methodology to basically unify these different properties. For example, top 1 accuracy in percent is very hard to compare to runtime in seconds. And runtime in seconds also relates is based on the execution environment that we use. So when we use more compute, use better hardware, more GPUs, then we are usually faster. But there's a trade-off there as well. So we have to unify all these different properties in some way, and then we have to report them. But we have to do this in a user-centric way. So users might say, well, I have this application here and I need a response every 2 seconds. Then they have very tight constraints on runtime. Maybe accuracy isn't even that important. Or they want to deploy it on a mobile phone, so they have memory limitations. So I think we here really have to take into account user objectives when we report on things. For that, I also implemented a front end that basically allows you to upload any evaluation database of machine learning results and showcase this trade-off. And this is exactly what I was talking about in terms of a resource versus quality trade-off in image classification. So you might have models that are very accurate up here, like near the y=1 axis. And you have models that are very fast, very small, consume very low amounts of energy at the x=1 position. And between them, you see a trade-off of optimization, basically. And this is something that you rarely find in papers. Usually people sell their method as the best in every comparison. That's how you get papers accepted. And with being more transparent of our trade-offs, we become more trustworthy in reporting. Another thing that I looked into is how we can come up with these AI labels. So I already mentioned that this methodology, sustainable and trustworthy reporting methodology, allows us to report on model performance and also do so in comprehensible ways. So every performance property that we investigate, we can just also communicate this in form of a color-coded badge or icon that allows you to understand that without any idea of machine learning. You understand this is about energy, this is about accuracy, this is about runtime, right? This is something that people can grasp even without studying computer science. We have these systems when we go to a store, buy a dishwasher. You don't have to be an expert in engineering. You don't have to be an expert in how water flows or what sort of liquid you use. You just know, I have 400 euros. This is the most efficient model I get for my use case. And this communication form is something that we need to establish in AI because everybody can use AI, but hardly anyone understands what AI is all about. Of course, when you do this, there's a lot of questions that you can ask yourself. Who actually needs labels? What are the requirements on AI and on labels? How does this affect their trust into a system? So because of that, we did a big interdisciplinary study. We asked a lot of people, had qualitative interviews. This was my first interdisciplinary collaboration, actually. So we worked with psychologists and sociologists about these questions and doing the whole analysis. So we did 16 interviews, we transcribed them, and then we went through all the interviews and coded every sort of comment on these labels in sort of some code from this diagram, answering either the question who and why we need labeling, how to label in the best way, what are the competitors to labeling, like other reporting forms, and how does trust play into this. And was a big study, was published 2 weeks ago at the AI conference on ethics and society. So yeah, if you're interested in that, feel free to read into that. And maybe as a sort of takeaway from this study, so we definitely saw clear benefits. A lot of people, when you look into this plot here, saw benefits, but they also saw limitations. So it's definitely not something that is finished. This is not the finished product. This is just the first step. What we concluded from our study is, first of all, labels really must strike a balance between, on the one hand, providing an overview that is accessible, and at the same time, still meaningful. So experts will still want to read into the paper. For them, it's too abstract. They want to take like the really detailed information in. But other people might not. So striking this balance is super important. Then labels actually do more than just presenting or documenting information. They actively shape decision-making. When we started our study, we basically asked people to describe their daily work and their daily problems. And from that, we asked them, what are your requirements on AI? And pretty much everyone said usability. Usability, it needs to be correct. We just need to get the right answers, all these things. After we discussed our labeling approach, some of them, and many of them actually, voiced up, well, actually, our company is really sustainably aware. Like, we are a green tech company. We actually want to be resource efficient, but only after seeing the label. So when we asked them in front, AI needs to be correct. And afterwards they said, well, it should balance efficiency and correctness. So this means labeling is not only about documenting information, it's actually about shaping decisions and also advocating sustainable development in a way. So they nudge people toward that behavior. The whole trust building aspect is much bigger than labels. There were studies investigating whether you can just put a trust seal on AI, like we have in e-commerce, trusted shops, you know, these labels. This is not feasible for AI. People don't really trust AI more because you just put a trusted stamp on it. So that's something that we also investigated, and this whole trust building process around AI is much bigger than what can be covered in a single label. But still, a label can be a way to, for example, come back to this different expectations thing and match people and connect them to understand more things. So it definitely can positively affect trust. And labels must allow for customization. This was a big coming out. When you talk with people in specific domains, they are actually very interested in very specific problems with very limited models being even applicable to that. And they need a customized label for this problem. They need to have the exact metrics that they investigate. When you ask people in health, doctors, like physicists, they usually have very specific metrics that they need to nail down. And they have, for example, this weird thing that our colleague Michael Kamp always says is, it actually doesn't matter how often it is right, but if it's wrong on the wrong, like if there's one super crucial decision where every doctor said, this is clear case of cancer, this is a clear case of cancer, and the AI says, no, it's not cancer, then the system loses all its trustworthiness. So it's not about like, on average, the system is right or wrong. This is, of course, also important, but it also, there's obvious cases where it needs to be right. And if it's not meeting that requirement, then we're never using it ever again. So using inaccuracy across 10,000 decisions might not be the best way to really inform these people, right? That's all coming to this customization aspect. Right, so let's move to the last topic, regulation for trust. There's many countries striving for AI regulation, and of course, trustworthiness is a big topic to that end. So there's a nice overview there I found online of like different states. In the US, we currently also have a case or have a situation where there's actually a lot of deregulation happening. This whole like liberal market thing is crashing in there. Currently, they just need to maximize their capital of AI, and they don't really want to think about how we can regulate it for trustworthy or sustainable or responsible use. But except for the US, most countries currently think about how can we regulate it. And of course, one of the biggest things is in Europe, the AI Act, which is shaping Europe's digital future. It's actually the first ever legal framework on AI in its scope that addresses the risks and positions the risk of AI, and it also positions Europe to play a leading role on a global level. It uses basically a hierarchical risk system. There's unacceptable risks, so in these cases, AI applications in the European Union are just not allowed and forbidden. In minimal and limited risk, it's not so problematic. And with high-risk applications, there's actually a whole process linked to it on how this needs to be regulated to meet legal demands. Also, one other thing that I just want to shortly mention here is, of course, that assessment lists and certification also plays into trustworthiness. So when you think about this whole process to high-risk AI systems, what will happen in practice is that companies that develop high-risk AI applications, they have to go through a very extensive assessment process. Basically, they have to really be clear about how they worked on this product, what the data was looking like that they used, how this whole development process looks like from the inside. And this can be achieved via assessments. So we have regulatory demand to report on trustworthiness, and one way to approach that is with expert assessments. So one thing that was actually also developed at Lamar Institute last year is a trust score derived from an assessment list. So you have an assessment list with different questions relating to the properties that I mentioned before, and experts judge if the AI systems meet these properties, meets these demands, and then from there they derive the trust score that can either relate to a specific model trained or also to the data set. So it's also about trust in data, which is connected to trust in AI, because without data we don't have any AI. And then another thing that was also developed at Lamar Institute and especially at Fraunhofer IAIS was this guideline for designing trustworthy artificial intelligence. It's a big assessment catalog, and this sort of connects to the second part of this lecture. But before we come to that, just a quick summary from my end. I think developing AI in trustworthy ways is mandatory, but not easy. So the question of trust and trustworthiness has so many dimensions, and it really necessitates collaboration across all disciplines. With the growing AI accessibility, people start to subconsciously trust and strengthen corporate power, but when being consciously asked about it, they actually don't trust it. So corporate power uses mechanisms and offers convenience and entertainment. And because it offers that, people use it a lot. But I think this is something that we really need to investigate more and be plain about. And I'm totally on for regulating them and not allowing them to just put AI out into the world and say, do whatever you want with it. You can generate funny videos. Let's go. And this way tricking people into trusting systems that they actually don't really want to trust. It's really important to improve trustworthiness, to map technical properties to desirable characteristics that we as humans use when we talk about trust. And to me, this is the key for trust calibration. And then lastly, regulation, of course, can be the crucial lever against the concentration of power that we currently have. It can foster trust, responsibility, and sustainable development. Now, short ad break. I mentioned that beforehand, so I'm also heading the Young AI Leaders in Dortmund. It's an initiative organized by AI for Good, happens on a global scale. All over the world, we have 100 hubs. One of them is here in Dortmund. It's not really a place or location. It's also co-located with Lamar, because I, as the hub leader, am also co-located with Lamar. All this auto-scrolling, should have disabled that. So we use AI for positive change in our world, just as the mission of AI for Good does. Sorry, I have to go back and forth here. What our community offers is hybrid meetings and activities. There's seminars and hangouts, like in the West Park, as you see here. We do a lot of technical and interdisciplinary exchange. We have a collaborative global network of the young AI leaders behind that. And it's actually open to anyone between 18 and 30. And it also doesn't require any prerequisite knowledge of AI. We have students in there. We have people working in there. So if you're interested, feel free to shoot me a message or just come around to one of the meetings. They are all open to attend. We also hosted, just around this, behind this wall, we hosted a workshop at the Digitalwoche, for example, where we talked about AI in societies, especially in Dortmund. And we are always looking for new members. So if you're interested in AI and maybe think about building your career on that, I mean, you're here, so apparently there's some interest, which is good. And if you think that AI should be used for good, then feel free to come around. Now, finally, to the slide that wants to open up all the time. One of the first big projects that we did is actually in context of the municipal elections, the Kommunalwahlen here in Dortmund. We used AI to visualize different programs of the election and basically analyze them and also visualize them in order to make political agendas a bit more accessible. There's so many people that are not really interested and maybe not able to read 40 pages of German text. Like, none of the election programs is available in English. That's for a start, and there's quite a few amount of people living in Dortmund that actually don't speak German. So for them, it's totally inaccessible. So we looked into how we can use that. And of course, we tried to be trustworthy in doing that. So we also wrote a scientific paper about that. And we specifically found a lot of limitations of using Gen AI for political education. So this is out there. You can read this. We deployed the whole pipeline of analyzing this in Dortmund here in our compute cluster of Lamar. We have a public webpage that you can check out, which is dortmund-wahl-ki.de. And yeah, so if anybody's interested in these results and wants to learn something about it. And we also plan follow-up, because in 2 years there's going to be North Rhine-Westphalia elections and then, of course, federal elections. So we think about maybe we can improve this whole system, maybe do it some more. And there's so much opportunities for research in this field. So if you're interested in that, feel free to reach out. That's it for me. Thank you for your attention. I'm open to any questions. You can also just add me on LinkedIn or shoot me a mail if you're interested in any of the stuff that I talked about today. And yeah, thank you for your attention.